Okay, let's have a look at the really important skill of cancelling down. And why is it important? Well, if I was to ask you to look at a sum like this, and you were to work this out longhand, you're going to invest a lot of time, a lot of energy, a lot of calculating, and a lot of ink and a lot of paper. So cancelling down often will allow you to work out sums like this much, much more easily. Let's have a look at a very straightforward one just to see how it works. 8 multiplied by 7 divided by 7. Any number multiplied by a number divided by the same number is going to take you back to where you started. So let's have a look at y. This is a fraction essentially, and we have a 7 in the numerator and a 7 in the denominator. And if we were to divide numerator and denominator by 7, well, 7 divided by 7 equals 1. 7 divided by 7 equals 1. So essentially what I've done is I've cancelled the 7 up here and the 7 down here to leave the 8. And that's how cancelling works. That's a really straightforward one because you've got the same number in the numerator and the denominator. Here you don't have the same number. But notice you do have 42 and 7. And 7 is a factor of 42. Notice also you've got 5 and 15, and 5 is a factor of 15. So we could split these numbers up and say that 5 times by 42, that is our 6 times 7. And if we divide that by 15, which we're going to split into two factors of 5 times by 3, multiplied by 7. Now it's much easier to see. We split these up and we can see, just like we had here, we have numbers on the top that are also on the bottom, so we can cancel them. And we can cancel our 5s. So what we've ended up with is 6 divided by 3, which equals 2, which is a lot more straightforward than working this out longhand. To make it even easier, you could have said that 5 over 15, well, you could divide the 5 and the 15 through by 5. 5 divided by 5 is 1, 15 divided by 5 is 3. So you could have done it in that way. And we're going to use that approach, finally, over here. Difference here is we don't have numbers which are factors of other numbers, but we do have numbers in the numerator and the denominator that have common factors. This is another opportunity to cancel down. So let's find some. 25 and 10. Common factor, 5. So if we were to divide 25 by 5, we get 5. If we divide 10 by 5, we get 2. What else do we have with common factors? 39 and 26. Common factor there is 13. And there are 3 13s in 39. 2 13s in 26. And what do we have here? 81 and 27. Do they have common factors? Yeah. Common factor there is 9. There is actually a larger common factor there as well. You might notice that 27 is a factor of 81. So we could just divide through by 27. 27 divided by 27 is 1. 81 divided by 27 is 3. So what we've now got is 5 times by 3 times by 3, divide that by 2, times by 1, times by 2, which equals 45 over 4. 45 over 4 equals 11.5. Notice we don't always end up with an integer answer. And notice also that I've made a small mistake there because that is, of course, not 11.5, it's 11.25. We don't always end up with an integer answer when we're doing these, but how much more straightforward is it to work out 45 divided by 4 than it would have been to tackle the original sum we had up here in green? So that's how we cancel down and why you will see it's so useful.
Okay, Mary, so let's let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.